Everything is working perfectly, trust me. Good evening, chat. Hello, everyone. Hi. Okay. Yeah, it's been a few days since I was last able to stream. I guess I should probably explain myself. So last week, I had my network, my internal network had a meltdown. Basically, my Switch somehow fried my router, and I had to get like a used router real quick. Thankfully, I had a friend who was able to lend me one. It was a router they weren't using anyways, so they kind of just gave it to me anyways. I think for the resub, White Bear, 2 months. Right. So yeah. Aside from that, you know, I was also away for like the entire weekend as well because I was attending a convention. Got a few merch from my vtuber mama. And yeah, it was very tiring because like I thought about slipping in the stream on Sunday, but I was just too tired to do anything. So yeah, here we are. Yeah, I guess for this week we've got, what do we have planned? Let me check. This week we have road trip. Yes, we are doing this a little bit on a bit of a weird day. Usually we reserve this for Saturday, but as you guys might know, my weekends are booked to hell, so I'm not available this weekend either. I might as well just do it now, I guess, to make up for the last Sunday. As for tomorrow, we're gonna try to do Build 42, Project Zomboid. And the day after, the next day would be Xenosaga on Thursday. So yeah, I know it's been a little bit unfortunate that we haven't been able to put any malware related stream on the weekends. It's a bit unfortunate as yeah, all the 4 consecutive weekends they're all booked. Thankfully I should return to normal next week. We'll see. Won't be available for Monday and Tuesday either, for next week. But after that, I think the weekend should be fine. That said, I'll also be gone again between September 21st through 28th because I'm going to Berlin for a talk. Yeah, now it's probably a good time to mention that I haven't finished working on the slides yet for that talk. I'm gonna have to figure that out this week. Anyways. Okay. So, back to driving. I guess. First of all, why is it running at 30 FPS? Does that help? Okay, it's back to 30, 32. Try 1080p 60. I might need to restart the game. Either that or the 60 FPS option is bugged. So I'm gonna have to turn the music off. Well, okay, whatever. We need to, first of all, how did this car get stuck? Okay, that's not what I meant when I said push. That's also not what I meant. Nope. We're gonna have to figure this out before we can continue reading. Hello? So if you're wondering what the buzzing sound is about, it's the freaking metal detector. I don't know why it's on. I need to turn that off. I can't even get in there. Okay. I need you to quiet down. No. Shh. Okay. I don't even know how this car gets stuck. Oh, no. There we go. Okay. Now it's moving. Okay. Or not. Okay, we're still stuck. Come on, you can do it. Come on. You can do it. Yeah. What are you stuck on? This? Oh, okay. Nope. Okay, now we can put the PDF back on. Okay. So, last time, I think we last left off on page 154. The game is running at like 38 frames per second. I think that's just the game's excellent programming. Not much I can do about it, I think. Because, like, it's using like 20% GPU. Anyways, yeah, I think last time we left off on page 154, which is terminating process. Let me double check the previous page to make sure. Yeah, I remember this experiment part. Okay. Terminating a process. A process is a container and a boundary. This means resources used by one process are not automatically visible to another in other processes. So some inter-process communication mechanism needs to be used to pass information between processes. Therefore, a process cannot accidentally write arbitrary bytes on another process's memory. Sorry, I had to process that sentence a little bit. Hang on. Okay. This will require an explicit call to a function, such as write process memory. However, to get that to work, a handle with the proper access mask, process VM write, must be opened explicitly, which may or may not be granted. The natural isolation between processes also mean that if some exceptions happens to one process, it will have no effect on other processes. The worst that can happen is that the same process would crash. The rest of the system would stay intact. Hang on. Before we go and continue, I need to double check what's in my car. What was that? Okay, you know what? Never mind. I'm just gonna not worry about it. A process can exit gracefully by calling the exit process function. For many processes, depending on the linker setting, the process startup code for the first thread calls exit process on the process's behalf when the thread returns from its main function. The term gracefully means that the DLLs loaded into the process gets a chance to do more work by getting notified of the process exit using a call to their DLL function if DLL process detach. I love just seeing the terrain deform right in front of me. Exit process can only be called by the process itself asking to exit. An ungraceful termination of a process is possible by using the terminate process function, which can be called from outside of a process. For example, Process Explorer and Task Manager use it when so requested. Terminate process requires a handle to the process that is opened with the process terminate access mask, which may or may not be granted. This is why it's not easy or it's impossible to terminate some of the processes, for example, CSRSS. The handle with the required access mask cannot be obtained by the requesting user. The meaning of ungraceful here is that DLLs don't get a chance to execute code. For example, the DLL process detach is not sent, and all threads are terminated abruptly. This can lead to data loss in some cases. For example, if a file cache has no chance to flush its its data to the target file. In whatever way a process ceases to exist, there can never be any leaks. That is, all processes' private memory is freed automatically by the kernel, the address space is destroyed, all handles to the kernel, objects are closed, etc. If open handles to the process still exist, the eProcess structure still exists, then other processes can still gain access to some process management information, such as the process exit code or get exit code process. Once these handles are closed, the eProcess is properly destroyed, and there is truly nothing left of the process. Okay, let's park here real quick and take a nap, because I can't see anything. That being said, if third-party drivers make allocations in the kernel memory on behalf of a process, say due to an LCTO or merely due to the exit due to process notification, it is their responsibility to free any such pool memory on their own. Windows does not track or clean up process-owned kernel memory, except for memory occupied by objects due to handles that the process created. This will typically be done through the IRP-MJ close or IRP-MJ cleanup notification to tell the driver that the handle to the device object has been closed, or through a process termination notification. See Chapter 6, IO Systems, for more on ILCTLs. Image loader. As we have just seen, when the process is started on the system, the kernel creates a process object to represent it and performs various kernel-related initialization tasks. However, these tasks do not result in the execution of the application, merely in the preparation of its context and its environment. In fact, unlike drivers, which are kernel mode code, applications execute in user mode, so most of the actual initialization work is done outside of the kernel. The work is performed by the image loader, also internally referred to as LDR or loader. The image loader lives in the user mode system DLL, ntdll.dll, and not in the kernel library. Therefore, it behaves just like standard code that's part of the DLL. It is subject to the same restrictions in terms of memory access and security rights. What makes this code special is that the guarantee that it will always be present in the running process until DLL is always loaded, and that is the first piece of code to run in user mode as part of a new process. Because the loader runs before the actual application code, it is usually invisible to the user and developers. Additionally, although the loader's initialization tasks are hidden, a program typically does interact with its interfaces during the runtime of the program. For example, whenever loading or unloading a DLL, or querying the base address of one. Some of the main tasks of the loader is responsible include initializing the user mode state of the application, such as creating the initial heap, and setting up the TLS or thread local storage and fiber local storage or FLS slots. Parsing the import table or the IAT import address table of the application to look for all DLLs that it requires, and then recursively parsing the IAT of each DLL, followed by parsing the export table of the DLLs to make sure that the functions is actually present. Special forwarder entries can also redirect and export to yet another DLL. Basically, kind of what some the DLL hijacking libraries do. Okay. Loading and unloading DLLs at runtime, as well as on demand, and maintaining a list of all loaded modules, also known as the module database. Handling manifest files needed for Windows Side-by-Side or XXS support, as well as multiple language user interface or MUI files and resources. Reading the application compatibility database for any shims, and loading the shim engine DLL if required. Enabling support for API sets and API redirection, a core part of one core functionality that allows for creating Universal Windows Platform or UWP applications. Enabling dynamic runtime compatibility mitigations through switchback mechanism, as well as interfacing with the shim engine and the application verifier mechanisms. As you can see, most of these tasks are critical to enabling an application to actually run its code. Without them, everything from calling external functions to using the heap would immediately fail. After the process has been created, the loader calls ntcontinue, a special native API to continue execution based on an exception frame located on the stack, just as an exception handler would. This exception frame, built by the kernel as we saw in the earlier section, contains the actual entry point of the application. Therefore, because the loader doesn't use a standard call or jump into the running application, you'll never see the loader initialization functions as part of a call tree inside of a stack trace for a thread. I guess this is what happens when you try to load an image in something like x64 debug, and you'll always see that it starts at NTDLL. This is referring to that initial loading stage, I guess. Experiment watching the image loader. In this experiment, you'll use the global flags to enable a debugging feature called loader snaps. This allows you to see the debug output from the image loader while debugging application startup. From the directory we've installed the WinDebug, launch the gflags application using the image file tab. In the image field, type notepad.exe, press tab key. This should enable various options. Select the loader snaps option, and then click OK. Now launch WinDebug, and choose Open Executable, and navigate to Notepad. You should see a couple of screens of debug information that's similar to what is shown here. Yeah, you can see there's a bunch of LDR prefix API calls in the output. Eventually, the debugger breaks somewhere inside the loader code, at a location where the image loader checks whether the debugger is detached and fires a breakpoint. If you press the G key to continue execution, ooh, okay. Oh, okay. That is a long road. It is a very long road and very bumpy road. Okay, I think our headlight fell off. At least we actually caught it this time, as opposed to finding that it's gone hours later. Yeah, let's put this on first. Oh, okay, well, that's a lot of blood. Yep, come on. Alright, on you go. Nope, no. That's not what I meant. Thank you. You'll see more message from the loader and notepad will appear. Try interacting with the notepad to see how certain operations invoke the loader. A good experiment is to open up the Save Open dialog box. This demonstrates that the loader not only runs a startup, but continuously responds to the thread requests that can cause delayed loads of other modules, which can be unloaded after use. So I want to try this real quick. Let's fire up our WinDebug. Give it a little bit. So G flags. I will need to answer. I will need to do UAC. Okay. If I do a screen capture, all right, window capture. Where is the window? Oh, there is. Okay, so this is what G-flag looks like. We'll find notepad.exe. Nope, don't want, there we go. Okay. Now we can, what was it, load snap or something? Load or snaps. Apply. So now when we open up WinDebug, let me move my thing over here. And we'll switch over to where did it go? Sorry, give me a second. I love when window capture just goes out of range of the Ah, there it is. Okay, so now launch executable. Make this bigger. Thank you. We'll hide the PDF for now. Okay, so we are at a debugger break. Wasn't it supposed to trigger? Hang on. Yeah, we did hit apply. I didn't see any messages. So let me try to load. Oh. Oh, there we go. I guess these mod load. Hang on. Stop debugging. We're gonna turn off loader snaps. I'm gonna see if that makes a difference in the things that it spits out. Hmm. Okay, this is with loader snaps turned off. I turn it on now. Restart. Huh. I thought it's supposed to show us the debug output for the loaders related stuff. Weird. Well, you know what? I think I'll investigate that later. Wonder why it doesn't do that. Let me double check. Show loader snaps. I only need to type notepad.exe. Yeah, let me try that again. No, that doesn't make a difference. Weird. Which notepad does start? Okay, what if I attach to one right now? Okay, I should probably... hang on. Should probably not show the process list. Not that there was anything incriminating, but... Where's Notepad? Notepad.exe. I have Notepad running right now. Doesn't show anything. Huh? Show process from all... Oh, I gotta run this as administrator. Oops. Hello, Crispy. Good morning. Okay, attach. Notepad. Attach. Now, does this make a difference? Okay, Notepad is frozen. Ow. Hello, Shane. Okay, notepad.exe. Come on, try this again. Nope, that still doesn't show me anything from the loader snaps. Damn. Well, I don't know why the experiment doesn't work. Oh well. It's fine. Hi, hello Shane. Okay. I'm gonna... Okay. Okay, now we're back to early process initialization. Because the loader is present in NTDLL, which is a native DLL that is not associated with any particular subsystem, all processes are subject to the same loader behavior, with some minor differences. Earlier, we took a detailed look at the steps that lead to the creation of a process in kernel mode, as well as some of the work performed by Windows function create process. Here, we'll cover all the other work that takes place in user mode, independent of any subsystem. As soon as the first user mode instruction starts execution. When the process starts, the loader performs the following step. First, it checks the if LDRP process initialized is already set to 1, or if the skip loader init flag is set in the TB. The thread, the environment block or something, I forgot. In this case, skip all initialization and wait 3 seconds for someone to call LDRP process initialization complete. This is used in cases where process reflection is used by Windows error reporting, or other process fork attempts where loader initialization is not needed. Reading a textbook while driving is worse than texting. This is bad influence on our youth. Have you tried reading a textbook on your phone and while driving before? You should give it a try. I'm just kidding, don't. I'm not responsible. I can't read? Me neither. I don't know what words are. It sets the loader init state to 0, meaning that the loader is initialized. Also sets the PB's process initializing flag to 1 and TB's ran process init to 1. Initialize the loader lock in the PB. Okay. Initializes the dynamic function table used for unwind and exception support in JIT code. Initializes the mutable read-only heap section, or MR data, which is used to store security relevant global variables that should not be modified by exploits. See Chapter 7 for more information. Initializes the loader database in the PEB. Initializes the national language support NLS for internationalization tables for the process. and builds the image path name for the application. It captures the structured exception handler from the PDA section and builds the internal exception tables. It captures the system call thunks for the 5 critical loader functions: anti-create sections, anti-create, anti-open file, anti-query attributes file, anti-open section, and anti-map view of section. It reads the mitigation options for the application, which are passed in by the kernel through the loader system DLL init block export variable. These are described in more detail in Chapter 7. It queries the IFEO registry key for the application. This will include such options such as the global flags stored in global flags, as well as heap debugging options, such as there was shadows, such as disable heap look aside, shutdown flags, and front-end heap debug options. Loader settings: unload event trace step, max loader threads, use impersonated device map, ETW settings, tracing flags. Other options include minimum stack commit in bytes and max dead activation context. So minimum stack commit in bytes is, I guess, somewhat documented, but like it never explained what it does in here. What are these shadows, man? As part of this work, the application verifier package and related verifier DLLs will be initialized, and control flow guard or CFG options will be read from CFG options. Have we been here before? Let's see. Well, there's a huge trailer, quote unquote. I'm not sure what that is. What do you call this part of a truck? The thing that gets towed. There's nothing inside. I have no idea what this. Oh, cigarette. Okay. Still a trailer? Oh, okay. What? Why is there a door here? And what is that bar that shows up? Huh? I'm very confused. Okay. Well, there's not a whole lot here, is there? Except a stuck door, which is not very helpful. And a door that leads to, nowhere. Don't jump off. I think that's a bale trailer. I'll take your word for it. Another door that leads to certain death. Very good. I need a flashlight. Alternatively, I should sleep. Why is my W key stuck again? Okay. Alright, give me a moment here. Okay. Yep, come on. Let me off. Thank you. Anything over here? Oh, a dead hand. Lovely. Severed limbs, whatever you want to call it. Nothing here. Nope, almost fell off. Wouldn't have been great. Okay. Well, let's get back on the road. That was a whole lot of nothing. Actually, hang on. You got anything in this cool... Nope. I don't think that's how physics work. Okay. Ooh. Is that a stool? Wow. Lovely. Okay. It looks inside the executable header to see whether it's a .NET application specified by the presence of a .NET specific image directory. If it's a 32-bit image, it also queries the kernel to verify that this is a WoW64 process. If needed, it handles a 32-bit IO image, which does not require Windows on Windows 64. It loads any configuration options specified in the executable image load configuration directory. These options, which a developer can define when compiling the applications, and which compiler and linker also use, to implement certain security and mitigation features such as CFG, control the behavior of the executable. It minimally initializes the FLS and TLS, the fiber local storage, and thread local storage. It sets up the debugging options for critical sections. It creates the user mode stack trace database if the appropriate global flag was enabled, and queries the... Okay. Well, that could be infinitely worse. You know what could be infinitely worse? Where did our trunk hood go? Not this one, but the one at the front. Did we lose it again? Hang on. When did it pop off? I hope that was a recent thing when it popped off. Because it would suck having to drive like this. I know I'm driving backwards. Just double checking. Actually, you know what? When's the last autosave? 22. Okay, you know what? Let's load it. Load that. That was not that long ago, anyways. We know there's nothing in here. I assume the trunk hood is still around. Oh no, it popped off a while ago. Oh. Well, that's bad news. Yeah, I want an earlier save. Nope, it was already missing at this point. How about this one? Oh, it was a... Wait. Oh, no. No. Oh, I think I just forgot to put it back on last time, did I? I mean, it's fine. It wasn't that long ago. So, not a big deal. It's like 1 page worth of driving time. Not insignificant, but also not the end of the world. Guess I'm reloading an earlier save just because my trunk hood popped off. It's a very reasonable thing to do. Okay. Initializes the heap manager for the process and creates first process heap. This will use various load configuration, image file execution, global flags, and executable header options to set up the required parameters. Enables the terminate process on heap corruption enables the terminate process on heap corruption mitigation if it is turned on. Initializes the exception dispatch log if the appropriate global flag has enabled this. Initializes the thread pool package, which supports the thread pool API. This queries and takes into account NUMA information. Initializes and converts the environment block and parameter block, especially as needed to support WoW64 processes. Opens the known DLL's object directory and builds the known DLL path. For a WoW64 process, known DLL 32 is used instead. For store application, it reads the application model policy options, which are encoded in win://package and dop://SKU ID claims of the token. See the app containers section in chapter 7 for more information. It determines the process current directory, system path, and default load path used when loading images and opening files, as well as the rules around default DLL search order. This includes the current policy settings for universal versus desktop bridge, or UDOP versus Centennial versus Silverlight, Windows Phone 8 package applications or services. I feel like Silverlight just kind of died down quietly. I haven't heard of Silverlight in a long time. I know it's EOL, but still. Kind of unrelated on tangent here. You guys know Microsoft had an official Silverlight tag in Taiwan, like about 10 years ago or something. Basically like the anime mascot for Silverlight. Yeah, so these Silverlight mascot, I guess it's not exactly tied to Microsoft, because like the current mascot, while under a different name, but it's got the same appearance. It's currently being used as part of a light novel or visual novel game that's, last I heard, was in development. I'm not sure if it's done already. That was like a year or two ago. Anyways, I still have merch from that era when they were clearing out the inventory. You know they have a official Silverlight body pillow? Yeah, that was a thing. I don't have it though, unfortunately, because by the time I saw the post, that was like a day late or something, where like the thing was already sold out. I managed to get the rest of the a lot of the other Silverlight merch that were available back then. Okay, it builds the first loader data table entry for NTDLO and inserts it into the module database. It builds the unwind history table. Initializes a parallel loader, which is used to load all the dependencies which don't have cross dependencies using thread pool and concurrent threads. It builds the next loader data table entry for the main executable and inserts it into the module database. If needed, it relocates the main executable image. If enabled, it initializes the application verifier. Initializes the WoW64 engine if this is a WoW64 process. In this case, a 64-bit loader will finish its initialization, and the 32-bit loader will take control and restart most of the operations we've described just up to this point. If this is a .NET image, Oh, I guess this area got regenerated. It's got a different trailer now. Hang on. Yo, hello. Goodbye. So I guess we have a different trailer, sorry, different truck now. Not very helpful, because it's missing all the wheels. Toilet? Okay. Water. I don't know what this is, but sure. Measuring tape? 13 feet. Holy shit. What? Why is there working measuring tape in this game? What? I can use it as a freaking hook. Cause like, look what happens when I hold down R. Pulls me in. Holy shit. The problem is, it's stuck. Um. Okay, I think the measuring tape is... Oh. Okay, I'm pretty sure the measuring tape is bugged. Let's try that again. Okay, this thing is bugged. That's not good. Oh, there we go. And that somehow hurt me a little bit. As indicated by the health bar. Okay, that was weird. Sure. Anything else funny up here? Wrong side of the ladder. And there's a door, which I assume leads to certain death. Yep, sure is. Oh. Look, we have a usable door now. Okay, let's see if this door is any better. Drop this off. Take a look later. I mean, Twitch is running an ad break now, so I guess we might as well take a break while we're at it. Be right back. Hello, I have returned. Okay, let's get back down to the car. Come on, off we go. Now let's see if we can use this door for anything. Do you think this fits on here? Oh, come on. I saw it. Wow, this looks absolutely ridiculous. Wait, is it made of wood? I mean, the insides, the interior. This looks absolutely stupid. As much as I want to keep it, I think I like this one where I can see the outside better. I love stupid doors, but that one's a little too stupid for me. What's up all these tumbleweeds? Okay. Let's put on some music while we're driving. For Windows, sorry. Right, I don't think we finished reading 32. If this is a .NET image, it validates it, loads mscore e.dll, the .NET runtime shim. I'm still not entirely sure what mscore e stands for. And it retrieves the main executable entry point, cor exe main, overriding the exception record to set this as the entry point instead of the regular main function. Initializes the TLS slots of the process. For Windows subsystem applications, it manually loads kernel32.dll and kernel.debase.dll, regardless of the actual imports of the process. As needed, it uses these libraries to initialize the SRP or safer, a software restriction policy mechanisms, as well as capture the Windows subsystem thread initialization function. Finally, it resolves any API set dependencies that exist specifically between these two libraries. It initializes the shim engine and parses the shim database. Enables the parallel image loader as long as the core loader functions scanned earlier do not have any system call hooks or detours attached to them, and based on number of loader threads that have been configured through policy and image file execution options. It sets the loader init state variable to 1, meaning import loading in progress. At this point, the image loader is ready to start parsing the image. At this point, the image loader is ready to start parsing the import table of the executable belonging to the application and start loading any DLLs that were dynamically linked during the compilation of the application. This will happen both for the .NET images, which will have their imports processed by calling into .NET runtime, as well as regular images, because each imported DLLs can also have its own own import table. This operation in the past continued recursively until all DLL had been satisfied and all functions to be imported had been found. As each DLL was loaded, the loader kept state information for it and built the module database. In newer versions of Windows, the loader instead builds a dependency map ahead of time with specific nodes that describe a single DLL with its dependency graph, building out separate nodes that can be loaded in parallel. At various points, when serialization is needed, the thread pool worker queue is drained, which services as a synchronization point. One such point is before calling all the DLL initialization routines of all the static imports, which is one of the last stages of the loader. Once this is done, all the static DLS initializers are called. Finally, for Windows applications, in between these steps, the kernel32 thread initialization thunk function, base thread init thunk, is called at the beginning, and the kernel32 post-process initialization routine is called at the end. Alright, before I continue, I'm going to move on to a different playlist, because this playlist is about to run out. Let me find a place to park first. Up here. Okay. Okay. DLL name resolution and redirection. Name resolution is the process by which the system converts the name of the P format binary to a physical file in situations where the caller has not specified or cannot specify a unique file to identity. because the locations of various directories, the application directory, the system directory, and so on, cannot be hard-coded at link time. This includes the resolution of all binary dependencies as well as load library operations, in which the caller does not specify a full path. When resolving binary dependencies, the basic Windows application model locates files in the search path, a list of locations that is searched sequentially for a file with matching base name. Although various system components override the search path mechanism in order to extend the default application model, the notion of a search path is a holdover from the era of the command line, when an application's current directory was a meaningful notion. This is somewhat anachronistic for modern GUI applications. However, the placement of the current directory in this ordering allowed load operations on system binaries to be overridden by placing malicious binary with the same base name in the application's directory, the technique known as binary planting. To prevent security risks associated with this behavior, a feature known as safe DLL search mode was added to the path search computation and is enabled by default for all processes. Under safe search mode, the current app directory is moved behind the 3 system directories, resulting in the following path ordering. First, the directory from which the application was launched. Second, the native Windows system directory. For example, C, Windows System 32. Excuse me. The 16-bit Windows system directory. For example, Windows System. The Windows directory. For example, Windows. The current directory at application launch time. Any directory specified by the path environment variables. The DLL search path is recomputed for each subsequent DLL load operation. The algorithm used to compute the search path is the same one used to compute the default search path. But the application can change specific path elements by editing the path variable using the set environment variable API. Changing the current directory using the set current directory API, or using the set DLL directory API to specify a DLL directory for the process. When a DLL directory is specified, the directory replaces the current directory in the search path, and the loader ignores this safe DLL search mode for the process. Callers can also modify the DLL search path for specific load operations by supplying the load with altered search path flag to the load library EX API. Let's take a nap first. Okay. But when this flag is supplied and the DLL name supplied to the API specifies a full path string. When this flag is supplied, the DLL name supplied to the path containing the DLL name is used in place of the application directory when computing the search path for this operation. Note that if the path is a relative path, the behavior is undefined and potentially dangerous. When Desktop Bridge or Centennial applications load, this flag is ignored. Whose blood is that? Certainly not me. I'm just kidding. It's definitely me. I slammed my head on the wheel a few times. But I'm alive. Barely. Other flags that applications can specify to load library EX include load library search DLL load directory, load library search application directory, load library search systems 32, and load library search user directories, in place of the load with altered search path flag. Each of these modifies the search order to only search the specific directory or directories that the flag references, or the flags can be combined as desired to search multiple locations. For example, combining the application system32 and user directories results in load library search default. Ow. Oh, our headlight fell off again. Results in load library search default directories. Furthermore, these flags can be set globally using the set default DLL directories APIs, which will affect all library loads from that point on. Another way search path ordering can be affected is if an application is a packaged application, or if it is not a packaged service or legacy Silverlight 8.0 Windows Phone application. In these conditions, the DLL search order will not use the traditional mechanisms and APIs, but will rather be restricted to the package-based graph search. So this is also the case when the load package library API is used instead of the regular load library EX function. This package-based graph is computed based on the package dependency entries and the UWP application manifest file, the dependency sections, and guarantees that no arbitrary DLLs can actually load in the package. Additionally, when a package application is loaded, as long as it is not a desktop bridge application, all application configurable DLL search path ordering APIs, such as the one we saw earlier, will be disabled, and only the default system behavior will be used in combination with only looking through package dependencies for most UWP applications as per the above. Unfortunately, even with safe mode search and the default path searching algorithms for legacy application, which always include the application directory first, a binary might still be copied from the usual location to user accessible location, for example, from System32 Notepad into C temp notepad.exe, an operation that does not require administrative rights. In this situation, an attacker can place a specifically crafted DLLs in the same directory as the application, and due to the ordering above, it will take precedence over the system DLL. This can be used for persistence or otherwise affecting the application, which might be privileged, especially if the user, unaware of the change, is elevating through UIC. To defend against this, processes and/or administrators can use process mitigation policy called Prefer System 32 Images, which inverts the order above between points 1 and point 2, as the name suggests. So yeah, it's referring to DLL side loading, a very common tactic that the legitimate developers and malicious actors use to load additional, possibly unwanted changes to various to the application itself. So for example, if we're talking legitimate uses, the most common would be for mods that use DLLs. For example, a lot of game mod loaders uses a dependency that hijacks the import table of the game itself, and then it's like, hey, I wanna you're looking for version.dll, right? Here's the version.dll right next to you. Use that instead. Since the game you likely would just use the default search order. I think it might go the other way actually. Since the application might use the default search order, it'll just take precedence and use the version.dll that it finds next to itself instead. And that version.dll contains proxy code that then launches the a forwarder entry that forwards the import either to itself or another DLL, which then starts the actual mod loader itself. Now, if we're talking like malware, right? What most malware developers typically do these days is instead of having a malicious executable .exe file, what they'll do is they'll put the DLL, the malicious DLL, right next to a legitimate and well-known executable that is vulnerable to search path hijacking. So, for example, one common example I saw a lot back in early 2020s was a few malware developers will take like an Avast binary, and then they'll just put a malicious Avast looking DLL right next to it. So when the executable is launched, it'll look like a legitimate executable because it is, and it is signed. And user will not necessarily know that the DLL next to it is malicious. So they'll just see a Avast binary running in the background, and they'll see that it's signed, and it looks like an application that the user knows and is familiar with, and it just lets it run in the background. Okay, another junction. Let's go straight. Now, typically, developers would change the previously mentioned load library EX flags in there to restrict the search order, so it's less vulnerable, but it's not, 100% foolproof. And many developers would typically just forget this thing, or just not know this option exists. I was trying to think of something else. You can find a list of all the vulnerable, DLL hijackable applications and executables in hijacklibs.net. I think it's .net. Let me check. It's hijacklibs.net. If you ever want to take a look yourself. I guess we're in the desert now. A similar thing to the search order mentioned here would be like, Linux has this very similar search order thing. Most commonly, though, when they want to sideload an application, they'll just call LD preload. That's also an option. But I'm pretty sure the same search order hijacking exists on Linux as well. So there's really no good way of getting around this issue, really. Aside from using the mitigations as mentioned earlier. Alright, come on. Let me out. Just a rock. Come on. You got this. Come on. Oh. Okay, come back here. Come on. Yep. Back. Thank you. DLL name redirection. Before attempting to resolve a DLL name string to a file, the loader attempts to apply DLL name redirection rules. These redirection rules are used to extend or override portions of DLL namespace, which normally corresponds to the Windows 32 Win32 file system namespace, to extend the Windows application model. In order of application, these are, first of all, men-win API set redirection. The API set mechanism is designed to allow different versions of or editions of Windows to change the binary that exports a given system API in a manner that is transparent to applications by introducing the concept of contracts. This mechanism is briefly touched upon in Chapter 2 and will be further explained in a later section. Give me a second, I want to check something real quick. hope I don't crash. Okay. Dot loco redirection. The dot loco redirection mechanisms allows the application to redirect the loads of specific DLL base name regardless of whether a full path is specified to a local copy of the DLL in the application directory, either by creating a copy of the DLL with the same base name, followed by a dot local. For example, mylibrary.dll.loco. Okay, let's fix this real quick. I hate how the headlight keeps popping off. Oh, we're missing one headlight again. God damn it. Really? Well, at least we still have one, I guess. How many times are we gonna lose the headlight? Like, shrunk is one thing, because, like, you know, when you lose the trunk, it's relatively noticeable. When you lose the headlight, though, it's kind of... It's tiny little thing just pops off and you never notice. Like, it's like screw. Or by creating a file folder with the .local under the application directory by placing a copy of the local DLL in the folder. For example, myapp.local/mylibrary.dll. I've never heard of this redirection rule before, huh? DLLs redirected by the .local mechanisms are handled identically to those redirected by SSX. See the next bullet point. The loader honors the .local redirection of DLLs only when the executable does not have an associated manifest, either embedded or external. It's not enabled by default. To enable it globally, add the D word dev override enable in the base IFEO key and set to 1. Fusion or SSX redirection. Fusion, also referred to as side-by-side, or SSX, is the extension of the Windows application model that allows components to express more detailed binary dependency information, usually versioning information, by embedding binary resources known as manifests. The fusion mechanism was first used so that applications could load the correct versions of Windows Common Controls Package, or comctls32.dll, after a binary was split into different versions that could be installed alongside one another. Other binaries have since been versioned in the same fashion. As of Visual Studio 2005, applications built with the Microsoft Linker Fusion uses Fusion to locate the appropriate versions of C runtime libraries, while Visual Studio 2015 earlier uses API set direction to implement the idea of universal CRT, or the C runtime. Okay, I need a sip real quick. The Fusion runtime tools reads embedded dependency information from the binary's resource section using the Windows resource loader, and it packages the dependency information into the lookup structures known as activation context. The system creates a default activation context as the system and process level at boot and process startup time, respectively. In addition, each thread has an associated activation context stack, with the activation context structure at the top of the stack considered active. The per-thread activation context stack is managed both explicitly via the activate act CTX and deactivate act CTX APIs, and implicitly by the system at certain points, such as when the DLL main routine of a binary with the embedded dependency information is called. When a Fusion DLL name redirection lookup occurs, the system searches for redirection information in the activation context at the head of the thread's activation context stack, followed by the process and system activation context. If redirection information is present The file identity specified by the application context is used for load operation. I'll be honest, this entire section just goes over my head without an example. It's fine. I'm sure. I totally understood all that. Okay. Before I continue, I need a restroom break. I'll be right back. I have returned. Okay. We should probably take a nap. It's like really late. I cannot see anything. Okay. Known DLL redirection. Known DLLs is a mechanism that maps specific DLL base names to files in the system directory, preventing the DLLs from being replaced with an alternate version in a different location. One edge case in the DLL path search algorithm is the DLL versioning check performed on 64-bit and WOW64 applications. If a DLL with a matching base name is located but subsequently determined to have been compiled for the wrong machine architecture, for example, a 64-bit image in its 32-bit application, the loader ignores the error and resumes the path search operation. Starting with the path element after the one used to locate the incorrect file, this behavior is designed to allow application to specify both 64-bit and 32-bit entries in the global environment path environment variables. Okay, let me dodge the rocks. Experiment. Observing DLL load search order. You can use this internals process monitor to watch how loader searches for DLLs. Sorry. When the loader attempts to resolve a DLL dependency, you will see it perform create file calls to probe each location in the search sequence until it either finds the specified DLL or the load fails. Here's the capture for the loader search for the OneDrive.exe executable. To recreate the experiment, do the following. I wonder why I used OneDrive specifically. If a OneDrive is running, close it from its tray icon. Open process monitor and add filters to show just. Okay, 3 of my 4 wheels fell off there. Could be worse. I could be dead. Optionally shows only the operation for create file. Sorry, wrong side. Go to local app data, Microsoft OneDrive, and launch OneDrive.exe or OneDrive personal.exe command, which launches OneDrive as personal rather than business. You should see something like the following. Note that OneDrive is a 32-bit process running on a 64-bit system. Here are some of the calls shown as they relate to the search order described previously. So yeah, as you can see, there's a bunch of create file here. Known DLLs load from the system location, while the 32.yellow in the screenshot. Login platform.yellow is loaded from a version subdirectory, probably because OneDrive calls setDLL directory to redirect searches. Okay, that's what I get for reading. Come on. Come on. Thank you. Redirect searches to the latest version, 17.3, and the screenshot. Okay, let's try that again. Why does the music sound like Pokemon? Battle music. The MSVCR 120.yellow, the MS version runtime, the Microsoft Visual C runtime version 12 is searched for within in the executable directory, and it's not found. Then it's searched the version subdirectory where it's located. The WSOC32 or WinSock is searching the executable path. Okay, I don't know what happened there. But that fell off again. Why is it always the headlight that falls off and not like the tail light or something? So how are we doing on fuel? Oh, we're doing fine. The search in the executable path, then in the version subdirectory, then finally located in the system directory, or syswow364. Note that the DLL is not a known DLL. Loaded module database. The loader maintains a list of all modules, DLLs, as well as the primary executable that have been loaded by a process. This information is stored in the PEB, namely in the substructure identified by loader, and called a PEB loader data. In this structure, the loader maintains 3 doubly linked lists, all containing the same information but ordered differently, either by load order, memory location, or initialization order. Oh, that's quite a flight there. Process monitor helped me understand so much. This internals in general is goated. Yeah, it really does help you, for example, figure out how the search order things work, because it logs all the create files. That's where acrobatics sure went flying there. These lists contain structures called loader data table entries, or loader data table entry in the variable name, that store information about each module. Additionally, because lookups and linked lists are algorithmically expensive, being done in linear time, the loader also maintains 2 red-black trees. I have no idea what a red-black tree means, which are efficient binary lookup trees. The first is sorted by base address, while the second is sorted by the hash of the module's names. With these trees, the searching algorithm can run in log arithmetic time, which is significantly more efficient and greatly speeds up the process creation performance in Windows 8 and later. Additionally, as a security precaution, the root of these 2 trees, unlike the linked list, is not accessible in the PEB. This makes them harder to locate by shellcode, which is operating in an environment where address space layout randomization, or ASLR, is enabled. I mean, it makes it harder for shellcode, but it's not like it's... Unless I'm reading this wrong, but aren't there like many other methods where you can do that? You can figure that out. Anyways, table 3-9 lists the various pieces of information the loader maintains in the entry. Fields in a loader data table entry. First of all, we have the base address index node, links this entry as a node in a red-black tree sorted by base address. Base DLL name, base name hash value. The name of the module itself, without the full path. The second field stores its hash using RTL hash Unicode string. I actually did not know of that function existing, huh? DLL base holds the base address where the module is loaded. Contains the new initialization routine of the module, such as DLL main. Contains the side-by-side fusion activation context when calling initializers for entry point activation context. Flags, loader state flags for this module. See table 3-10 for description of the flags. Border links, a linked list of modules that were loaded as a result of export table forwarders from the modules. Okay, I'm not going to read through all of these. You can read through these or look at the PB structure yourself, because this is a very long table. Oh, interesting. Actually, so you know what? I should at least read through the names, because some of these are interesting. Forwarder links, full DL name, It's a fully qualified path name, so that should be absolute path. Hash links, implicit path options, list entry links. I don't know why this one has space. When it's like, isn't this supposed to be a variable name? Load context, obsolete load count, load reason, why this was loaded, load time, stores the system time value when this module is being loaded, mapping info index node, original base, before ASLR relocation, it contains the original base address, parent DLL base, signing level. This stores the signature level of this image. Okay. Size of image, switchback context, time date stamp, a timestamp written by the linker when the module is linked, and TLS index. Sorry, let me sip through my drink real quick. Yep. Oop. Give me a second. Actually, hang on. I ran out of tea. I'm gonna go run downstairs real quick and grab one. I'm not gonna switch to a BRB screen because that's gonna trigger the ad. I'll be right back. I have returned. Give me a second. Okay, I've returned for real. I probably should pause the game because the car was running. Okay. One way to look at the process loader database is to use WinDebug and format output of the PEB. The next experiment shows you how to do this and how to look at the loader data table entry structures on your own. Experiment. Dumping the loaded module database. Before starting the experiment, perform the same steps as the previous two experiments to launch notepad.exe with WinDebug as the debugger. When you get to the initial breakpoint where you've been instructed to type G until now, follow these instructions. Okay, so we'll start WinDebug right now. Okay, there it is. So we'll start notepad.exe. You can look at the PAB of the current process with the PAB !PAB command. For now, you're interested only in the loader data that will be displayed. Okay. Okay, so there it is. The address shown on the loader line is a pointer to the PEB loader data structure described earlier. Notice that WinDebug shows you the address of the 3 lists and dumps the initialization order for you. Oh, it does. So there's the loader initialized, loader in initialization order module list, loader in load order module list, loader in memory order module list. So you have the full path timestamp base address of each module. You can also analyze each module entry on its own by going through the module list and then dumping the data at each address, formatted as loader data table entry structure. Instead of doing this for each entry, however, WinDebug can do most of the work by using the !list extension in the following syntax. Okay, we'll copy that. Invalid expression. All right, what did I type wrong? DT !DLO load at C++ and at $PB loader. Sorry, what did we do wrong? Why is that? What? Yeah, how about we just type it out normally? Maybe there's something went wrong with copying. Entry C++ and at $PB loader and load order module list. Okay, there we go. Okay, so now it's showing us each entry for, the entries for each module. Which is a lot of them. Because they're like all of these modules that are loaded. Can I see? I should be able to see the same thing with with x64 debug, right? Let me try that. Now, obviously, it's not going to use the same syntax, but where's x64 debug? There it is. Okay. Oh, I have an older version of x64 debug. I should probably update it. Okay. Notepad.exe. Okay, so how do I go to the PEB of the... You know, I need AI's help. You can use the built-in PEB function. Oh. Okay, let me show you the window real quick. Yeah, I've loaded up Notepad again. And if we type... make this bigger for you guys. If I type PB... okay, you can't see it. There we go. If I type PB as a function, it'll just take me to where the PB is, which is here. Now how do I parse the PB in here? I know there's a struct here, but... I might need to update to a later version of x64 debug, because I know something similar has been added in the latest version. Let me do that real quick. x64 debug, x64 debug, releases. Ooh. Unrelated, but there's now an improved scripting in the latest version of x64 debug. I should really look into x64 debug documentation more. Okay. Where is it again? Where did I put it? eTools x64 debug. There it is. No, I don't want to delete. I accidentally hit the delete button. Okay. Thankfully, I wasn't a permanent delete. Okay. Okay, let's try that again. x64 debug. Okay, we are on a later build now. So if I open up notepad.exe, there we go, the PB. I know there should be a method to view parse PB structure in here, but where do I do that? Okay, I'm pretty sure there's an easier way to do this because I've seen this in previous revamp type system. Okay, display type. No types loaded yet. Parse a header first. Okay, parse header. Allows you to parse C header files directories and results directly in x64 debug. Add supports for bit fields, enums, and anonymous types. Okay, so anything in the WinDebug SDK should be able to load it. in here. So let me take a look at the Windows SDK real quick. I should be able to find the PB structure in there, right? Okay. I go take a look here. Sorry guys, this is gonna take a little bit. No results found. Okay, it is not in the Windows SDK. What if I copy these and then paste it and tell it to read this? Parse header. Failed to parse header. Struct is not a type. What do you mean you can't read the struct? Man.
New subscriber!
Thank you for the resub, blank. Well, okay, whatever. I'll figure out how to read parse PB in here later. That's annoying. I was hoping to be able to see it in Win64 debug. Oh well. Okay. Although this section covers user mode loader and then DDLL, why am I stuck? Hello? Hello? That's one way to get unstuck, sure. Okay, although this section covers user mode loader and NTDLL, note that the kernel also employs its own loader for drivers and dependent DLLs. With a similar loader entry structure called kloader data table entry instead. Likewise, the kernel mode loader has its own database of such entries, which is directly which is directly accessible through PS active module list global data variable. To dump the kernel's loaded module database, you can use a similar !list command as shown in the preceding experiment by replacing the pointer at the end of the command with !PS active module list using a new structure module name. So list nt kloader database table entry nt ps active module list. Looking at the list in raw format gives you an extra insights into loader's internals, such as the flags field, which contains state information that PEB on its own will not be able to show you. See table 3-10 for their meaning. Because of both the kernel and user mode loader uses this structure, the meaning of flags is not always the same. In this table, we explicitly cover the user mode flags only, some of which may exist in the kernel structure as well. Okay. Take a nap. And I need a restroom break. Be right back. Okay, I have returned. Sorry for all the breaks going through this stream. I think I've had too much tea. Okay, kind of need those tea when I'm speaking long term, anyways. Package. Okay, so loader table data table entry flags. Package binary. This module is part of a package application. Marked for removal. Module will be loaded as soon as all references are dropped. Image DLL. Load notification sent. Telemetry entry processed. Process static import. And legacy list. And index shim DLLs. An exception table. Load in progress. Load config processed. Entry processed. Protect delay load. Process attach called. Process attach failed. Don't call for threads. COR deferred validate. COR image. Don't relocate. COR ILO only. Compat database processed. Etc. etc. You can read that table on your own because it's a very long table. Import parsing. Now that we've explained why the loader keeps track of... Now we've explained the way loader keeps track of all modules loaded for a process, you can now continue analyzing the startup initialization tasks performed by the loader. During this step, the loader will do the following. First, it will load each DLL referenced in the import table of the process's executable image. Check whether the DLL has been loaded, and by checking the module database. If it doesn't find it in the list, the loader opens the DLL and maps it in memory. During this mapping operation, the loader first look at the various paths where it should attempt to find this DLL, as well as whether this DLL is a known DLL, meaning that the system has already loaded it at startup and provided a global memory map file for accessing it. Certain deviations from the standard lookup algorithm can also occur, either through the use of a .local file, which forces the loader to use DLLs in the local path, or through a manifest file, which can specify a redirected DLL to use to guarantee a specific version. After a DLL has been found on disk and mapped, the loader checks whether the kernel has loaded it somewhere else. This is called relocation. If the loader detects relocation, it parses the relocation information in the DLL and performs operations required. Okay. If no relocation information is present, DLL loading fails. The loader then creates a loader data table entry for this DLL and inserts it into the database. After a DLL has been mapped, the process is repeated for this DLL to parse its import table and all of its dependencies. After a DLL is loaded, the loader parses the IIT to look for specific functions that are being imported. Usually this is done by name, but it can also be done by an ordinal, also known as an index number. If you don't know, a DLL can export various function names, but it can also just each of the function names also has an ordinal attached to it, which is the number that is associated with it. For example, number 1 might stand for, I don't know, load me or something. But it can also just not have a name. It could also just be, like, for example, there might be an ordinal 2 that doesn't have a name. So, like, for example, when you want to load such DLLs, like when you want to load a regular DLL and run DLL, you call run DLL, followed by the DLL name and the export name. And if the export name doesn't have an actual name, you use the ordinal instead, which is indicated by the hash name, the hashtag sign in front of the digit. For example, you call run DLL, my DLL.dll, comma, hash 2 to call the second ordinal in the DLL name my DLL. For each name, the loader parses the export table of the import DLL and tries to locate a match. If no match is found, the operation is aborted. The import table of an image can also be found. This means at lake time, the developers already assigned a static address pointing to an import functions in an external DLL. This removes the need to do the lookup for each name, but assumes that the DLLs the application will use will always be located at the same address. Question, which side did we come from? Let me look at the blog. Okay, so we're going uphill. Okay. Alright, come on. Oh, did I not pull the handbrake? God damn it. Okay, we're going that way. Just remember that. Come back here. Ah, back. Oh my god. Stop. Going downhill. Get back here. Well, at least I ran into a tree. And a cactus. Okay, I guess we're running. Because Windows uses address-based randomization, see Chapter 5 for more information on ASLR. This is usually not the case for system applications and libraries. Okay, I think we're going like... Okay, so we came from this way, yeah. The export table of an imported DLL can use a forwarder entry. This means the actual function is implemented in another DLL. This must be essentially treated like an import order dependency. So after parsing the export table, each DLL referenced by a forwarder is also loaded, and the loader goes back to step 1. There's a lot of DLL hijack loaders do. Like only one of the functions will contain one or more functions will contain a malicious code or other unintended code, while the others are just forwarder entries, so that the application will continue to operate normally. After all import DLLs and their dependencies or imports have been loaded, okay, I see a house. Where did our backside go? Well, good to know that we need to go find yet another trunk hood. Very good. Do you have an unused trunk hood around here? Wow, this frame rate. No, there's a severed foot. And a car, a very rusted car, that has no trunk hood. Not very helpful. Ah, light was on. Crunchy floor pastry. Anything in here, or is it just piss? That's diesel. No piss in sight. Nothing useful here. Okay. Anyone here? Okay, you know what? I don't want to investigate. I'm pretty sure I'm gonna fall off if I do that. Okay, whatever that is. Another door. Oil. Okay, we can use that. truck. Ooh, a hat. Okay, I can't see myself, but I'm sure it's a good hat. Okay, and there's not much here, unfortunately. I will take that. I will take the oil, though. Okay, cool. Come on. There we go. After all import DLLs and their own dependencies and or imports have been loaded, all the required imported functions have been looked up and found, and all folders have been loaded and processed. The step is complete. All dependencies that were defined at compile time by the application and its various DLLs have now been fulfilled. During execution, delay dependencies, also called delay load, as well as runtime operations such as load library, can call into the... Yeah, we need headlights and the trunk hood. Can call into a loader and essentially repeat the same tasks. However, note that a failure in these steps will result in an error launching the application if they're done during process startup. For example, attempting to run an application that requires the function that isn't present in the current version of operating system can result in a message similar to figure 3-12. Which says notepad.exe entry point not found. The procedural entry point, create dialog param, cannot be located in the DLL library user32.dll. I think this is also when the if you try to load a bad image, it also spells the same error around this part. Post-import process initialization. After the required dependencies have been loaded, several initialization tasks must be performed to fully finalize launching the application. In this phase, the application will do the following. These steps begin with loader init state variable set to 2, which means imports have been loaded. The initial debugger breakpoint will be hit when using debuggers such as WinDebug. This is where you had to type G to continue execution in earlier experiments. Check if this is a Windows system sub-application. Check if this is a Windows subsystem application, in which case base init thread thunk function should have been captured in the early process initialization steps. At this point, it is called and checked for success. Similarly, the term serve get Windows directory Windows W function, which should have been captured earlier, if on a system which supports terminal service, is now called, which resets the system's and Windows directory path. Using the distributed graph, it recurs through all dependencies and run initializers for all of the image's static imports. The step that calls DLL main routine for each DLL, allowing each DLL to perform its own initialization work, which might even include loading new DLLs at runtime, as well as processes the TLS initializers for each DLL. This is one of the last steps in which loading an application can fail. If all the loaded DLLs do not return a successful code after finishing the DLL main routine, the loader aborts starting the application. Nope. What does caps lock do? Huh? I just hit it by accident, so I have no idea what that actually does. What does caps lock do? Smoke or hum? Oh. Wow. This is the most useless thing they added in this game. I love it. Okay. If the image uses any TLS slots, call its TLS initializer. I'd ask it join, but I think my Wi-Fi sucks so much we suffer. That, and I think that it makes the game lag a lot more. It's fine. Don't worry about it. Run the post-initialization shim engine callback if the module is being shimmed for the application compatibility. Run the associated subsystem DLL post-process initialization routine register in the PEB. For Windows application, this does terminal services specific checks. For example, at this point, write an ETW event indicating that a process has loaded successfully. Whoa. Okay. Not what I meant to do, but sure. Whatever. If there is a minimum stack commit, touch the thread stack to enforce an end page of the committed pages. I think this is what minimum stack commit in bytes does, specifically here. Set loader in its state to 3, which means initialization is done. Set the PEB's process initializing field back to 0, then update the LDRP process initialized variable. Okay, we need to take a break. Here we go. I cannot see anything. Sorry, where are we going? I guess I didn't pull the handbrake. Okay. Let's get back to the road before we continue reading. I think it drove backwards. I mean, as long as we're not the one driving backwards, that's fine. Switchback. As each new versions of Windows fixes bugs such as race condition and incorrect parameter validation checks in existing API functions, an application compatibility risk is created for each change, no matter how minor. Windows makes use of a technology called switchback, implemented in the loader, which enables software developers to embed a GUID specific to the Windows version they're targeting in the executables associated manifest. For example, if a developer wants to take advantage of improvements added to Windows 10 to a given Windows 10 API, she would include the Windows 10 GUI GUID in her manifest. Why is it referred to as she all of a sudden here? Not that it really matters, it's just jarring. While if a developer has a legacy application that depends on Windows 7 specific behavior, she would put the Windows 7 GUID in a manifest instead. Switchback parses this information and correlates it with an embedded information in switchback compatible DLLs. In the .sb_data image section, to decide which version of an effective API should be called by the module. Because switchback works at a loaded module level, enables the process to have both legacy and current DLLs concurrently at the same, calling the same API, yet observing different results. Switchback GUIDs. Windows currently defines GUIDs that represents compatibility setting for every version from Windows Vista. So there's Windows Vista through 10. These GUIDs must, I guess we'll turn right. These GUIDs must be present in the application manifest file under the support OS element in the ID attribute in the compatibility attribute entry. If an application manifest does not contain a GUID, Windows Vista is chosen as the default compatibility mode. Under Task Manager, you can enable an operating system context column in the Details tab, which will show if any applications are running with a specific OS context. An empty value means they're operating in Windows 10 mode. And Figure 3-13 shows an example of few such applications, which are operating in Windows Vista and Windows 7 modes, even on a Windows 10 system. So I think this is probably in this is probably in Process Explorer as well. Let me check that. So I assume this is operating system context column. Yeah. On mine, I can see that most of them are running under Windows 10 context. Some of them running under Windows 8. Some of them running under Windows 7. Some of them under Vista as well. But you can see this in both your Task Manager and System Informer. Yeah, like this. Operating system context. Switchback compatibility mode. A few examples of what switchback can do. Here's what running under Windows 7 context affects. RPC components use the Windows Start pool instead of a private implementation. Direct draw log cannot be acquired on the primary buffer. Bleeding on the desktop is not allowed without clipping window. Raise condition and get overlap result is fixed. Calls to create file are allowed to pass a downgrade flag to receive exclusive option to receive exclusive open to a file when the caller does not have a write privilege, which causes NT create file to not receive the file disallow exclusive flag. Just a moment. Okay, running in Windows 10 mode. Running in Windows 10 mode, on the other hand, solely affects how the low fragmentation heap behaves. By forcing the LFH subsegments to be fully committed and padding all allocations of a header block unless the Windows 10 GUID is present. Additionally, in Windows 10, using the raise exception on invalid handle close mitigation, see Chapter 7 for more information, will result in close handle and rich close key respecting the behavior. On the other hand, on previous operating systems, if the debugger is not attached, this behavior will be disabled before calling NT-close, and then re-enable after the call. So, I haven't seen OS context mentioned basically anywhere else. And I was like, I already have the column enabled on my System Informer before, but I didn't really know what it does, or what it really means. So I guess it's explained here. As another example, the spell checking facility will return null for languages that don't have a spell checker, while it returns an empty spell checker on Windows 8.1. Similarly, the implementation of the function iShellLink resolve will return e-inval-arg when operating in Windows 8 compatibility mode when given a relative path. We will not contain this check in Windows 7 mode. Okay. Excuse me. Get back on there. Thank you. Furthermore, calls to get version x, ex, or the equivalent functions such as RTL verify version info will return the maximum version number that corresponds to the switchback context GUID that was specified. Note that these APIs have been deprecated, and calls to get version ex will return 6.2 on all versions of Windows 8 or later if a higher switchback GUID is not provided. Switchback behavior. Whenever a Windows API is affected by changes that might break compatibility, the function's entry code calls SB switch procedure to invoke switchback logic. It passes along a pointer to the switchback module table, which contains information about the switchback mechanism employed in the module. The table also contains a pointer to an array of entries for each switchback point. This table contains a description of each branch point that identifies it with a symbolic name and a comprehensive description, along with an associated mitigation flag. Typically, there will be several branch points in the module, one for Windows Vista behavior, one for Windows 7 behavior, etc. For each branch point, the required switchback context is given. It is this context that determines which of the two or more branches is taken at runtime. Finally, each of these descriptors contain a function table to the actual code that each branch should execute. If the application is running with the Windows 10 GUID, this will be part of its switchback context and the SB select procedure API. Upon parsing the module table, we'll perform a match operation. It finds the module entry descriptor for the context and proceeds to call the function pointer included in the descriptor. Switchback uses ETW to trace the selection of a given switchback context and branch points and feeds the data into Windows AIT, also known as the Windows Application Impact Telemetry Logger. I had never heard this before. This data can periodically be collected by Microsoft to determine the extent to which each compatibility entry is being used. Identify the application using it, a full stack trace is provided in log, and notify a third-party vendor. As mentioned, the compatibility level of the application is stored in its manifest. At load time, this loader parses the manifest file, creates a context data structure, and caches it in the pshim data member of the PEB. This context contains the associated compatibility GUID that this process is executed under, and determines which version of the branch point and the APIs that employ the switchback will be executed. This entire paragraph about switchback is flying over my head. API sets. While switchback uses API redirection for specific application compatibility, nice flip, for specific application compatibility scenario, there's much more pervasive redirection mechanism used in Windows API for all applications called API sets. It's nice sideway flips. I should be getting some stun points for this. Its purpose is to enable fine-grained categorization of Windows APIs into sub-DLLs instead of having large multi-purpose DLLs that span nearly 1,000 APIs, which might not be needed on all types of Windows system today and in the future. This technology developed mainly to support the refactoring of the bottommost layer of Windows architecture to separate from higher layers. It goes hand in hand with the breakdown of kernel 32 and ADV API 32, among others, into multiple virtual DLLs files. For example, Figure 3-14 shows a screenshot of Okay. Apparently that rock was so strong at just yoinked both of our wheels off, including a door, and stopped us dead in tracks. Come on, you got this. Here we go. Figure 3-14 shows a screenshot of Dependency Walker, where kernel 32, which is a core Windows library, imports from many other DLLs, all beginning with API-ms-win. Each of these DLLs contains a small subset of APIs that kernel 32 normally provides, but together they make up the entire API service exposed by kernel 32. The core string library, for example, provides only the Windows-based string functions. Oh, so that's what these things do. I've seen these API-ms-win DLLs so many times already. I thought it was just like modern Windows stuff. So it's like, I guess some of the DLLs are just like split into various tiny chunks of DLLs instead. I mean, that makes sense. I don't believe I've seen it as frequently as before on previous iterations of Windows. Are we blocked? Wait. Ooh, nice spin. We have a large roadblock ahead. Might have to go drive around this. Oh, but first of all, we've got a little house to visit. Come on, get out of here. Got this. Come on. Come on. Get out of there. Come on. Oh. Lovely. Is that a bat?
This is my place.
Oh, yeah?
Place wants me to be here. Don't run away. Just stay.
Average FPS players.
Stay. Just stop.
Alright, come over here. And stay still. Come on.
Run, and you can hide.
Not shot in the dick. Do we still have... Yes, we do. Okay. How do I... Right-click R plus mouse. Right. Wait. No. How do I... Oh, R. Okay. Okay. There we go. Nothing in here. Alright, it's about to be nighttime. I need to take a nap. Oh man, this is a nice looking car. It's missing all the parts though. And a trunk. Hood. Okay, let's take a nap first because I can't see anything. meantime, I need another restroom break. I'll be right back. Man, I've heard this song so many times now. It's been on my Nikkei's lobby screen for like many days, many months. Internet not good. Roommate working from home. I can hear him in Teams call. My condolences. Okay. This goes on the back, right? Yeah. Or actually, I don't think this belongs to this car, does it? Unless it goes on the front. Or not. Okay, it really does go on the back. I don't know why there's a little thing there. Binoculars. Door. Bridge. Tire. Okay, that's a whole lot of nothing here. Sick car. Too bad it's all broken. Or like, rather it's missing parts. Right, so we drive along this here. I'm gonna save real quick. Just in case. In splitting functions across discrete files, two objectives are achieved. First, doing this allows future applications to link. Okay. Okay. Now, all things considered, only the trunk fell off. Trunk hood fell off. Could be worse. Could be infinitely worse, actually. Like dying. Now we get back up there. Sad because I did a long drive run, forgot to turn off food and water, and died while driving with a full tank gas oil. Yeah, that's why I turned it off. I think we had something similar when we first started. I don't think this game needs more survival elements to make this game more difficult. It's already pretty difficult as is. Okay, so there's a go left and go right. Left will be blocking the way. So I guess this is the correct way then. Or rather, the only sensible way for us to go. First, doing this allows future application to link only with the API libraries that provide the functionality that they need. Second, if Microsoft were to create versions of Windows that did not support, for example, localization, say a non-user-facing, English-only embedded system, it would be possible to remove the subDLL and modify the API set schema. This will result in a smaller kernel 32 binary, and any application that ran without requiring localization would still run. With this technology, a base Windows system called MinWin is defined, at the source level, built. With the minimum set of services that include kernel core drivers, including file systems, basic system process such as CSRS, and service control manager, and a handful of Windows services. Windows Embedded, with its platform builder, provide what might seem to be a similar technology, as system builders are able to remove select quote-unquote Windows components such as shell or the network stack. However, removing components from Windows leaves dangling dependencies, code paths that, if exercised, would fail because they depend on removed components. MinWin's dependencies, on the other hand, are entirely self-contained. I drove for 2-3 hours IRL. After that, I stopped playing. Understandable. I think I did the same thing first time I played. My record so far is 97 kilometers. I think we're at like How many kilometers are we at? 631. I've been driving for a while. When the process manager initializes, it calls the PSB initialize API set map function, which is responsible for creating a section object of the API set redirection table, which is stored in system root system32 API set schema. The DLL contains no executable code, but has a section called .api set that contains API set mapping data that maps virtual API set DLLs to logical DLLs that implement the APIs. Let me take a look at that real quick. API set schema .dll. So there's a 150 kilobyte file on my system. So I open up the API set schema file right now. Show it to you guys. You'll see that it's a bunch of non-data templates, executable. Where did the template view go? Template results, there is. Yeah, as you can see, it's mostly addresses and a bunch of strings to the API MS Win DLL files. No executable code in here. It does have a PDB file. It does have a PDB defined still though. Okay. Whenever a new process starts, the process manager maps the section object into the process's address space and sets this API set map field in the process's PEB to point to the base address where the section object was mapped. In turn, the loader, I still know what the P stands for, LDRP apply file name redirection function, which is normally responsible for the .local and side-by-side fusion manifest redirection that was mentioned earlier. Also checks for the API set redirection data whenever a new import library that has the name starting with API dash loads, either dynamically or statically. The API set table is organized by the library, with each entry describing in which logical DLL the function can be found, and that DLL is what gets loaded. Although the schema data is a binary format, you can dump its strings using system hurl strings to see which DLLs are currently defined. Yeah, that was what we saw earlier in 010 editor. Jobs. A job is a nameable, securable, shareable kernel object that allows control of one or more processes as a group. A job object's basic function is to allow a group of processes to be managed and manipulated as a unit. A process can be a member of jobs, although the typical case is just one. A process's association with a job object can't be broken, and all processes created by the process and its descendants are associated with the same job object, unless child processes are created with the create breakaway from job flag, and the job itself has not restricted it. The job object also records basic... Okay. Also records basic accounting information for all processes associated with the job and for all processes that were associated with the job but have since terminated. Jobs can also be associated with an IO completion port object, which other threads might be waiting for. With the Windows get queued completion status function, or by using the thread pool API, the native function TP thread pool, alloc job notification. This allows interested party, typically the job creator, to monitor for limit violations and events that could affect the job security, such as new process being created or a process. I feel like this game has a very creative liberty on what things fall off when you run into things. Because like how did me running into a rock cause the two wheels to fly off? How does that even happen? Okay. Jobs play a significant role in a number of system mechanisms enumerated here. They manage modern apps, or UWP processes, as discussed in more details in Chapter 9 in Part 2. In fact, every modern app is running under a job. You can verify this in Process Explorer as described in the Viewing the Job Object experiment later in this chapter. They're used to implement Windows container support through a mechanism called server silo, covered later in this section. They are the primary way which Desktop Activity Moderator, DAM, manages throttling, timer virtualization, timer freezing, and other idle-inducing behaviors for Win32 applications and services. The DAM is described in Chapter 8 in Part 2. They allow a definition and management of scheduling groups for dynamic fair share scheduling, DFSS, which is described in Chapter 4. They allow for the specification of a custom memory partition, which enables the usage of memory partitioning API described in Chapter 5. They serve as a key enabler for features such as run as, secondary logon, application boxing, and program compatibility assistant, or PCA. They provide part of security sandbox for applications such as Google Chrome and Microsoft Office Document Converter, as well as mitigation from denial of services attacks through WMI requests. Job limits. The following are some of the CPU, memory, and IO-related limits you can specify for a job. First of all, there is the maximum number of active processes. This limits the number of concurrently existing processes in a job. If this limit is reached, new processes that should be assigned to a job are blocked from creation. Job-wide user mode CPU time limit. This limits the maximum amount of user CPU time that the process in the job can consume, including processes that have run and exited. Once this limit is reached, by default, all processes in the job are terminated with an error code, and no new process can be created in the job unless the limit is reset. A job object is signaled, so any threads waiting for the job will be released. You can change this default behavior with a call to set information job object to set the end of job time action member of the job object end of job time information structure passed with the job object of job. Why are those? Take a sip every time I say the word job. Of the job object end of job time notification structure passed with the job object end of job time information class and request a notification to be sent through the job's completion port instead. That's a lot of jobs. Per process user mode CPU limit. This allows each process in the job to accumulate only a fixed maximum amount of user mode CPU time. When the maximum is reached, the process terminates, with no chance of cleaning up. Job processor affinity. This sets the processor affinity masks for each process in the job. Individual threads can alter their affinity to any subset of job affinity, but processes can't alter their process affinity setting. Job group affinity. This sets a list of groups to which the processes in the job can be assigned. Any affinity changes are then subject to the group selection imposed by a limit. This is treated as a group-aware version of a job processor affinity limit. Okay. Legacy. It prevents that from this limit from being used. I thought wheel fell off. Apparently not. Okay. Jobs process priority class. This sets the priority class for each process in the job. Threads can't increase their priority relative to the class as they normally can. Attempts to increase thread priorities are ignored. No errors are returned on calls to the set priority call, but the increase doesn't occur. I feel like that should return an error. Like, logically speaking. Maybe just me. Okay. Default working set minimum and maximum. This defines the specified working minimum. This defines the specified working set minimum and maximum for each process in the job. This setting isn't job-wide, and each process has its own working set and same minimum and maximum values. Okay. Process and job committed virtual memory limit. This defines the maximum amount of virtual address space that can be committed by either a single process or the entire job. CPU rate control. This defines the maximum amount of CPU time that the job is allowed to use before it will experience forced throttling. This is... Careful. This is used as part of a scheduling group subport described in Chapter 4. Network bandwidth rate control. This defines the maximum outgoing bandwidth for the entire job before throttling takes effect. It also enables setting a differentiated service code point, or DSCP tag, for QoS purposes for each network packet sent by a job. This can only be set for one job in the hierarchy. It affects the job and any child jobs. Disk I/O bandwidth rate control. This is the same as network bandwidth rate control, but is applied to disk I/O instead. It can control either bandwidth itself or the number of I/O operations per second, or IOPS. It can be set either for a particular volume or for all volumes on the system. For many of these limits, a job owner can set specific thresholds, at which point a notification will be sent, or if no notification is registered, the job will simply be killed. Okay. Additionally, rate control allows for tolerance range and tolerance intervals. For example, allowing a process to go beyond 20% of the network bandwidth limit for up to 10 seconds every 5 minutes. And these notifications are done by queuing an appropriate message to the IO completion port of a job. See the Windows SDK documentation for more details. Finally, you can place user interface limits on processes in the job. Such limits include restricting processes from opening handles to windows owned by threads outside of the job, reading and or writing to the clipboard, and changing many user interface system parameters via Windows System Parameters Info function. These user interface limits are managed by the Windows Subsystem GDI or user driver. 132K sys, and are enforced through one of the special callouts that is registers with the process manager, the job callout. You can grant access to for all processes in the job to specific user handles, for example, window handle, by calling user grant handle grant access function. This can only be called by a process that's not part of the job in question, naturally. Okay, I think we are gonna call reading today. The reading part took, but yeah, we're gonna end for the reading because my throat is starting to get tired. Pixel 10 drops today. I've seen, allegedly there's, not allegedly, apparently there is a Pixel pop-up shop in Taipei somewhere. I've not gone there yet because I only just found out it existed like 2 days ago on Threads. I would like a Pixel at some point. My 2 phones ago, I was on a Pixel 3 XL. I actually still have the case for it, but I sold the phone long ago. Apparently it's a flop. I've heard it's like marginally better, and like I know the camera is like the main unit is worse than a regular 9. You know, if I were to switch to a Pixel, I'd probably get the fold one. I kind of want a fold phone, like a fold for like a tablet alternative, but they're also stupidly expensive. The specs on the 10 Pro XO is crazy, yeah. So the main reason why I want a Pixel these days is mainly because it can run Graphene OS. I would like to try going full Google-less, quote unquote, for the software side, but like not as my main phone, like a secondary phone, just to see how well it works for me, because I'm not entirely sure how well it will work for anything that requires payments, contactless payments, or that uses contactless payments. Because, you know, I kind of want to still use Google Wallet. 58 megapixel wide, 48 ultra wide, macro focus. Yeah, I've heard of the 100x zoom thing that uses generative AI. That's probably one of the few interesting uses of Gen AI. But I haven't seen any reviews that mentions it, that actually puts it in action yet. I've seen a hands-on video of the phone. That's about it. Actually, I'm more interested in the Pixel Watch than anything, for something that is a little bit more affordable than a full-on phone. Because like my phone works fine, you know. I just need a phone that works, really. These days, I'm not too fussed about the camera or other features. I don't even use the wireless charging much on my phone, even though it exists. (120 Hz display). Not 4K like the Xperia. I mean, the modern Xperias are like 1080p these days. 1080p 120. I think we'll end the stream and next time we see a house. Which could be either really soon or really long, really far away. Oh. Well, at least the car didn't. Oh, come on. Okay. So I think that's the first time I ever, like, reattached the part while in the car. You know, I haven't been able to justify the purchase of a smart device yet. Or, like, smart wearable. The last time I did, it was, a used Tech Watch Pro, which died, which is pretty slow in modern standards. And it's outdated, security-wise. And the time before, house. And the time before that was, I mained a Pebble Time for the longest time. I know they're coming up with a new Pebble now, like they kind of revived the Pebble brand a little bit. I'll be honest, I think I'd be more interested in a new Pebble than Pixel Watch. As much as I like the idea of a full Android smartwatch, I think a Pebble Time is probably something as simple as a Pebble is a lot less distracting. Is that a taxi? Where is he? Where are you? Where are you? Hello? Sounds like he's very close. Are you upstairs? Where are you? It sounds like he's very close. It's spooking the hell out of me. I don't know where he is. It's freaking me out. I think he's like upstairs somewhere. Don't think I can get up there. Okay, whatever. Oil. Alcohol. It's a lot of alcohol. Didn't know wiki labels farmers and zombies. They sure are. Where is this guy, man? Why is there alcohol in the oil tank? Doc, get down here, wherever you are. I think there is a second level in these buildings, but I don't know how to get up there. I don't think there's a hidden basement. I think he's just up there. Don't know how to get to it, though. Anyways. Refill the fuel. Oil. Sounds like he's right next to me. It's freaking me out. Alright, come on. Get in there. Come on. No, I don't want to drink it. Come on. Yeah. Okay. So, we've driven for, I want to say 3 hours today. Man. My throat is dying. Okay. Let's see who we can raid. If anyone. Wait, who's this that raided us before? Hang on. Let me see. Up a following. Okay, let's raid whoever this raided us before. Why are they talking about tasting pee? Okay, you know what? Have fun. I'll send you guys over. I'll see you guys later.